Imagine the head teacher of a school wanted to know what their students thought about their maths lessons. Clearly, to answer this, the head teacher will need to ask the students, perhaps to complete a survey. In this situation, the head teacher has a choice. They could ask every single one of the students at the school to complete the survey, or instead they could ask just some of the students to complete the survey. When we collect data like this, there's some terminology you need to be aware of. Firstly, the word population. This is used to describe the whole set of items that are of interest. In our example, the population is all of the students that attend the school. The word census refers to when all of the items of the population are observed or measured. This would be the case if the head teacher asked all of the students to complete the survey. Instead though, the head teacher may conduct a sample. This is where a subset of the population is observed or measured instead. For our example, this would be if the head teacher asked some, but not all of the students to complete the survey. For example, they might ask all of the students in one particular class, or the students whose surname begins with the letter A, or even a completely random sample of students. All of these would be examples of a sample. You need to be aware of the advantages and disadvantages of a census and a sample. The main advantage of a census is it gives a completely accurate result. This is because it includes every member of the population. A sample, on the other hand, may not accurately reflect the whole population. For example, what if the head teacher only selects students from a particular math set, or from a particular teacher? This might not accurately reflect the views of all of the students in the school. In terms of the disadvantages of a census, well, firstly, it takes a very long time in comparison to a sample, since every member of the population needs to be observed or measured. It could also be expensive depending on what's being sampled, and because of the sheer amount of data that might need to be processed afterwards. A sample, on the other hand, should be quicker to conduct and cheaper as well. Another problem with a census is that it's not always possible or practical depending on what's being investigated. For example, if we're testing items and it's destroyed in the process, then a census can't be used. Now don't be confused, I'm not suggesting we destroy children here who don't like maths. Let's think of a different example. Imagine we had a company that makes batteries, the type that you would put into a child's toy that would eventually run out. The company would need to test batteries until they're completely empty of charge. Then at this point they would dispose of the battery. They can no longer sell it because it's been used up. Side note here, don't throw your batteries in the bin, you can recycle them at most local supermarkets. The point here is that each battery that's tested is no longer useful to the company and therefore can't be sold. If the company did a census, they'd have no batteries to sell at all, so it doesn't make sense to do so. They would definitely want to use a sample. Another example could be companies that make mobile phones. They may want to test how high the phone could be dropped before it breaks. Each of the phones that's tested in this way could no longer be sold, so if they did this to every phone they produced, they'd have no phones to sell. So once again, they'd want to use a sample rather than a census. In terms of samples, it's important to appreciate a few points. Firstly, larger samples are generally going to be more accurate. In the original example, imagine the school had over 1,000 students. A sample of 3 students is likely to be significantly less accurate than a sample of 30, and that will be less accurate than a sample of 300. So the more students we include in the sample, the greater the accuracy, all the way up to when we do a census, which is the greatest level of accuracy you can have. You also need to appreciate that different samples can produce different results. In our original example, imagine the head teacher took a sample of students and 87% of them said they love maths. Well, if they chose a different sample of students, they may get a different result. It could be only 73% of students that love maths. The only way to get a fully accurate result is to do a census, but sometimes remember, that's not practical. Next we'll need to look at some more terminology. Sometimes when we take a sample, we use a sampling frame. A sampling frame is a complete list of the entire population that is either individually named or numbered. In our example, the sampling frame could be a giant register of all of the students in the school. This is a list that's individually named. All of the items in the sampling frame are known as sampling units. So in this one, all of the students' names are the sampling units. Some people struggle to understand the difference between the terms population and sampling frame. The key thing to remember is that the population is all of the items that are of interest, but the sampling frame is the list of all of these items. In some situations, a sampling frame is not actually possible or might be unknown. Imagine we had a beekeeper and they wanted to know some information about the bees that are in a hive. Before they begin sampling bees, it's unlikely they'll know how many are in the hive, and the number of bees might change over time. Creating a numbered or named list of all of the bees would also be very difficult. It would require the beekeeper to be able to distinguish between each of the bees. Now I'm no bee expert, but to me bees generally look the same. If it was possible to distinguish between each of the individual bees, it's likely a census would have already been conducted anyway. Now let's try some exam questions on this topic. So in this one we've got Karen who's organising a street party for everyone that lives on her street. And she's going to contact her potential guests to check their dietary requirements. We're going to answer these questions. First of all, we're going to suggest a suitable sampling frame from which we can obtain a sample. So the sampling frame, remember, is a list of all of the items in the population. The population here would be all of the people that live on Karen's street. So the sampling frame would be a list of all of the names of the people who live on Karen's street. Remember, it needs to be an individually named or numbered list of the population. Then we need to identify the sampling units. The sampling units would simply be a person who lives on Karen's street. And for the final part, we need to decide if Karen should use a sample or a census and give a reason for the answer. So we need to have a little think about this. Now, unless Karen has a very, very big street, a census is probably the most sensible option here. If you think about the data that Karen's collecting here, it's dietary requirements, and this could be potentially important. For example, if somebody's allergic to a particular food item, like nuts, it's worth Karen knowing this. So we could say that dietary information is important. You don't want to miss anybody out in this situation. And also it's likely that the census won't be too large unless Karen lives on a giant street. Now let's take a look at a second example. In this one, we have a tyre manufacturer that creates a brand new tyre to sell to a car company. The car company orders 10,000 of the new tyres, but wishes to know how many miles the new tyres will last before they need replacing. The questions we're going to answer are as follows. Part A, define the population. So the population is all of the items that are of interest. So this would be all of the 10,000 tyres produced by the manufacturer. Notice we didn't need to say a list of all of the tyres here, because this is not a sampling frame, it's just the population. For part B, we need to explain why a census would not be suitable. Well, if we're testing these tyres up to the point where they need replacing, after we finish testing the tyre, it can't be used again. So if we were to test all of the tyres, there'd be no tyres left for the car company. So we would say, each tyre that's tested cannot then be used again. If all 10,000 tyres were tested, there'd be no tyres left. Next, we're going to look at the different ways of sampling. There are 6 methods we're going to cover in this video, and we can split them into 2 categories, which are random sampling and non-random sampling. We'll start with random sampling. When we choose a sample, we hope that it will be representative of the whole population. One way to do this is to use random sampling methods. In random sampling, each item of the population, or sample of items, has an equal chance of being selected. If a sampling method means that some samples are more likely to be selected than others, we say that this method is biased. Let's take a look first of all at simple random sampling. To do simple random sampling, you're first of all going to obtain a sampling frame and number each of the items. Then you're going to generate random numbers to select the items. You ignore any repeated numbers, and you just continue until the desired sample size is reached. Let's have a look at an example of this in action. So imagine we wanted to sample 4 of the 20 Premier League football teams. The first thing we need to do is obtain a sampling frame and number it. So this would be a numbered list of all of the 20 possible Premier League football teams. It would look something like this. Next, we need to generate some random numbers to determine which football teams we're going to include in our sample. Often the best way to do this is using a calculator. I'll show you how we do that now. First of all, we press Catalog, go down once to Probability, then press Execute, go down again until we hit Random Integer, since we want random whole numbers between 1 and 20. We press Execute and it puts this code onto the screen. We then press 1 because our lowest number is 1, then we press comma, we need to do Shift and bracket to do this, and then the number 20, and we close this bracket. This command here, if we press Execute, will give us a random number between 1 and 20. So let's press it, and we get the number 2. So since the first number generated was number 2, and this corresponds to Aston Villa, we're going to include Aston Villa in our sample. Then we continue generating random numbers until we've got 4 teams. So let's generate another random number by pressing equals again, and we get 19 this time. 19 corresponds to West Ham, so they're going to be in the sample. Then we do this again, and the next random number we select is 16, so that's Nottingham Forest. And then we go once more. And notice this time we've got a repeat. So we've got 19 again, which is West Ham, but we already have West Ham, so we're going to skip that one and continue again. If we do it one more time, hopefully we don't get a repeat this time, and we get the number 5. So the number 5 is Brighton, and we've completed our sample because I said we wanted a sample of size 4. So that's how you do simple random sampling. Some of you may be using an older style calculator than this one, so I'll just show you quickly how to do this as well. If you want to generate a random number, you can see at the bottom of the calculator in red here, it says randint. So we press shift and then alpha, then this decimal point button, and it puts randint on the screen. Then we can do as we did before, 1, 20, and then close the bracket. That'll give us a random integer between 1 and 20. Now you also need to be aware of the advantages and disadvantages of each sampling method. So for simple random sampling, the main advantage is there's no bias. This is because each of the items has an equal chance of being selected. Secondly, it's quite cheap and easy to do if the population or sample size is quite small. You saw before it didn't take us very long to generate that sample for the Premier League football teams. This is because the population and sample were small. In terms of disadvantages, well, it requires a sampling frame, and remember before we said a sampling frame is not always possible. Another disadvantage is that it's quite expensive or time consuming if the population or sample is large. Imagine instead if we were sampling football fans at a football game. There could potentially be tens of thousands of people in the sampling frame. When you generate a random number from tens of thousands of people, you then have to go through the list and find that person, and that could take a long time. The next sampling method we're going to look at is known as systematic sampling. To do this, we first of all obtain a sampling frame and number each item, just like we did with simple random sampling. Then we're going to divide the population size, which is capital N, by the sample size, which is lowercase n, and this gives us k. We randomly select a number between 1 and k and include this item in the sample. Then we sample every kth item after this one. Let's have a look at what this looks like in practice. Imagine a company produced light bulbs and they had a population of 60 light bulbs that they wanted to sample to test them for faults. First of all, they need to create a sampling frame, so we're going to number all of the light bulbs. Then we have capital N, which was the size of the population, so all of the light bulbs, that's 60, and then lowercase n, which is our sample size. And let's say for sake that the sample size the company wants is 10. So we have a population of 60 light bulbs and we want a sample of 10 of them. We can then work out this value of k by doing capital N, which is 60, divided by lowercase n, which is 10, and 60 divided by 10 is 6. The next step is to randomly sample one of the first 6 items because k is 6. So we need to randomly select one of these 6 light bulbs, and you could do this using a random number generator on your calculator. Let's say for this example we randomly generated number 5. We then take each kth item after this one. Since k is 6, we need to take each 6th item after this one. To do this, you can continually add 6 to the number of the most recent item that you sampled. So we sampled item number 5, and if we add 6 to 5, we get 11. So we need item number 11. If we add 6 to this, we get 17. Add 6 to this, we get 23. And we just continue doing this, going through the list, adding 6 each time, until we get to the end. You'll notice when you get to the end, you'll have the required number of items. So here we have 10 items, which was our sample size. There are some things you need to be aware of though with systematic sampling. Let's go back and do this example again, but change the sample size. Rather than 10 this time, we want a sample of 12. Now this will change the value of k. Instead of 60 divided by 10, we do 60 divided by 12, which will give us k of 5. So we're going to randomly sample one of the first 5 light bulbs. Now let's say for example we sampled number 2. We then take every 5th light bulb after this one. So light bulb 7, 12, 17, and so on. So we'd end up with this sample here. You can see there are 12 light bulbs in this sample. So this is one of the possible samples, but we didn't have to choose this one. We may have randomly selected light bulb number 1, in which case we would have had this sample. We could have selected light bulb number 3, in which case we would have had this sample, or 4, and this sample, or 5, and this sample. Now what this means is there's only actually 5 possible samples that could have been selected, these 5 here. It's not possible, for example, to select a sample that includes light bulb number 1 and light bulb number 2. They just can't be in the same sample. In fact, most samples can't be sampled at all. It's just these 5 here. This is a problem because it can introduce bias. Earlier on in this video, I said that if some samples were more likely to appear than others, then the method would be considered biased. And in this example here, there's only 5 possible samples at all, so some samples aren't possible. Therefore, these 5 are more likely to appear than all of the other ones. There is a way around this though, and it very much depends on how we take the initial sampling frame. In this example, it might be that the company just takes light bulbs out of the machine as they appear. This could be problematic because faults may occur at regular intervals. It might be that due to the machine making the light bulbs, every fifth light bulb is faulty. In which case, all of our samples will be fine apart from the one that starts with 5, where all of those light bulbs will be faulty. To eliminate this bias, you could ensure that your sampling frame itself is random. So rather than the light bulbs being assigned in order that they come out, the numbers are assigned to the light bulbs in a random fashion. This would remove the bias from the system. Another example of this could be if the sampling frame was a list of people in alphabetical order, like this one here. It may well be the case that people listed next to each other are in the same family because they have the same surname. If we did this in a systematic way, then P Abbott and S Abbott can't be included in the same sample. So it might be that you randomize the sampling frame before continuing with the systematic sample. There's one more thing we need to look at with systematic sampling. Imagine we had a population size of 63 and we wanted a sample of 8. When we compute the k value, we do 63 divided by 8, which gives us 7.875. Now this is problematic because it's not an integer. The next step in the method is to randomly sample one of the first k items. Now how can we randomly sample one of the first 7.875 items? That doesn't make much sense. And then we would sample every 7.875th value after this one. Once again, that doesn't make any sense. So we're going to have to adapt the method to cope with this. One way to do this is as follows. Instead, we randomly sample one of the first 7 items. For example, the item number 4 could be selected at random. Then we take each 8th item after this point. So item 12 all the way down to item 60. You can see this is a sample of size 8. If we randomly sampled item number 1, then we would have this sample, also of size 8. If it was number 2, we'd have this sample, 3, 5, 6, and 7. So you can see here there are still 7 possible samples of size 8. But this does have one drawback, and that's with these items here. These items cannot be sampled at all. However, this is the best we can do in this situation if k doesn't give you a whole number. We can still use most of the data in the sample, but not all of it. But this is the best we can do in this situation where k is not a whole number. Now let's look at the advantages and the disadvantages of systematic sampling. So in terms of advantages, it's simple and easy to use. It's good for large populations, so even when the population is large, it's quite easy to work through the list. The disadvantages are that it requires a sampling frame again, much like simple random sampling. Sometimes a sampling frame isn't possible, so we wouldn't be able to use systematic sampling. Finally, if a sampling frame is not random, the method could introduce bias. That's what we talked about earlier with the light bulb example. The way around this is to try and ensure that your sampling frame is random before you begin. This doesn't necessarily mean you need to randomize the sampling frame before you begin, you just need to be aware that it could introduce bias. For example, if there was some sort of periodic trait of the population in the way it was listed, like every 5th light bulb was faulty. Now let's have a look at the next sampling method. This one is called stratified sampling. Stratified sampling is where the proportions of groups based on some characteristic are the same in the sample and the population. To do this, we split the population into groups, which we call strata, based on some characteristic. This characteristic might be gender, eye color, age, basically anything you can do to categorize the population into different groups. Then we determine the total sample size, and then we calculate the number needed from each of these groups, or strata, to ensure the sample and the population have the same proportions. Once we have these numbers, we then sample the required amount of each of the groups, for example using simple random sampling again. Let's have a look at what this looks like with an example. So in this example, we have a theatre that sells 800 adult tickets, 250 child tickets, and 150 senior tickets. So that's going to be our population. The theatre wishes to take a stratified sample by type of ticket of size 200. We need to work out how many of each ticket type would be in the sample. So we need to ensure that the proportion of each of the ticket types in the whole population is the same as that in our sample. To do this, we use the following formula. The number in the sample will be the proportion in the population multiplied by the sample size. We'll do this for each of the type of tickets, and we'll start with adult tickets. So using this formula, the number of adult tickets in the sample will be the proportion of adult tickets in the population multiplied by the sample size. So if we look at the population, you can see we had 800 adult tickets. To write this as a proportion, we need to know the total number of tickets. So if we add together all of the tickets, we have 800 plus 250 plus 150, which is 1,200. So the proportion of adult tickets in the population is 800 over 1,200. Then we just multiply this by the sample size, which is actually given in the question. It says it's 200. You can type this into a calculator and you get 133.3 recurring. We'll do the same process for children next. So we need the proportion of child tickets in the population. There were 250 child tickets out of 1,200. Then we multiply this by the sample size, which is 200. This gives you 41.6 recurring. And finally for senior tickets. There were 150 senior tickets in the population, so the proportion is 150 over 1,200. And then we multiply this by the sample size of 200, which gives you 25. Now the number of adults, children and seniors in the sample need to be integers. We can't have 133.3 recurring adults, so we're going to round these to the nearest whole number. So in the sample, we'll have 133 adults, 42 children, and 25 seniors. At this point, it's worth adding these together to check it does add up to the sample size, and these do add together to give 200 as required. But sometimes this won't happen, and there is a problem I want to highlight now. Imagine the sample size was not 200 and it was 100. Well, in the formula, the only number that's going to change is the multiply by 200, it will become multiply by 100. If we do this for the adults, we get 66.6 recurring. If we do this for the children, we get 20.83 recurring, and for the seniors, 12.5. Now again, we need to round each of these to the nearest integer. So the adults would be 67, the children 21, and the seniors 13. If you add up all of these though, you get 101, which was not the required sample size. This means we've got an extra person in our sample that we don't want. Well, the question is, who are we going to remove? This problem has occurred because all of the numbers were rounded up to give the nearest integer. In terms of which one you're going to remove, you're going to choose the number that was rounded up the most. This would be the number 12.5, since if it was any lower, it would actually have been 12. It's the one that's had the greatest amount of rounding applied to it. So instead of 13 seniors, we'd actually opt for 12, which will now give us the required amount in the sample of 100. As with the other methods, we need to talk about the advantages and disadvantages of stratified sampling. The first advantage is that the sample structure will reflect that of the population. Remember, we have the same proportion in the sample as we do in the population. It also ensures that no groups are under or overrepresented. When you do a method like simple random sampling, it's completely possible that all of the people you sample will be from one particular group, and some groups might not be represented at all. So stratified sampling is a good way around this. The first disadvantage is that the population needs to be split into distinct groups, which we called strata. Imagine if we were sampling people based on what games console they had. Well, some people may have one games console, but some people may have two, so where would we include those people? Or imagine it was people attending a football match, and we wanted to sample them based on which team they support. Well, it's possible that some people support both of the teams, in which case the strata won't be distinct. Another disadvantage is that sometimes it's difficult to classify all of the items into the strata. If we go back to the example of football supporters at a football game, it may be that some of the people at the football game don't support any of those teams at all, or perhaps one supporter supports a completely different team that's not playing on that day. This could mean it's difficult to classify them for the purposes of what you're investigating. And for the final disadvantage, we need to remember that stratified sampling concludes with a simple random sample of each of the strata. This means it has the same disadvantages that simple random sampling has as well. For example, it requires a sampling frame, and it can be difficult for particularly large samples or populations. Next, we'll move on to our final method of random sampling, and it's known as cluster sampling. Important information, this is only on the exam board AQA. So if you don't do AQA, I'd skip on to the next chapter, but if you do AQA as your exam board for A-level maths, I'd stick around. So cluster sampling looks like this. We take the population and split it up into different clusters based on a certain characteristic. You then number each of these clusters, and then you randomly select some numbers to represent those clusters by simple random sampling. So let's say for this one we wanted to sample 3 of the clusters. We would use random number generators, like on a calculator, to select 3 random numbers and pick those clusters. So let's say for example we picked cluster number 1, 9, and 10. Once you've identified the clusters you're going to use, you then sample everybody within those clusters. So if this was the one we did, our sample would look like this. Let's have a look at an example of where cluster sampling might be useful. Imagine the management at McDonald's wanted to know how their employees at their restaurants felt about their work. Well, McDonald's is quite a large company. In the UK, there are roughly 1,400 restaurants and 135,000 employees, so it would be quite an undertaking to ask all of them. Instead, what they could do is split the population up into clusters, based on which restaurant they worked at. So they could have 1,400 different clusters, each one the name of a store. They would then randomly sample as many of these clusters as they wanted. Let's say they wanted to sample 20 clusters. They would randomly sample 20 of these clusters using simple random sampling. And then once they've got these clusters, they sample everybody who works at these restaurants. Let's discuss the advantages and disadvantages of cluster sampling. First of all, it's relatively cheap and easy to do. The method itself is not complicated. You select some clusters and then sample everybody at that cluster. Another example is the groupings are already known or documented. So those clusters naturally exist. McDonald's will already have a list of all of the employees at each of the restaurants, so there's no extra work involved there. In terms of disadvantages, some clusters may not represent the population well, as the items within a cluster may share similarities. It could easily be the case that employees that work at the same restaurants have similar views, because they experience the same conditions. Next we'll move on to the non-random sampling methods, and there are only two of these we need to look at. First of all, we're going to look at what we call opportunity sampling. This is sometimes called convenient sampling. For this method, we simply take a sample from the population of the items that are available at the time that fit the criteria we're after. An example of this might be to try and get the opinions of people that have gone to watch a new film. A researcher could stand at the exit to the cinema and then just ask people as they come out the door to fill in a survey. There's no random selection involved at all. You can see it's highly convenient for the researcher. They simply ask the first available person that comes out of the door and then continue with this until they've asked enough people for their sample to be completed. This is why it's sometimes called convenient sampling as well. Let's talk about the advantages and disadvantages of this method. Well, first of all, it's very cheap and easy to do. It's the most straightforward form of sampling. In terms of disadvantages, it's not random at all, and this means it could be biased. It can also be somewhat dependent on the researcher themselves. In our example, the people that have watched the film may be more or less likely to talk to certain researchers based on anything about them really. It could be their personality, their height, their age, their gender. Anything that makes somebody more or less likely to stop and give their opinions on the film is affecting their likelihood of being included in the sample, and is therefore biased. The final type of sampling we're going to talk about is known as quota sampling. Quota sampling is a bit like a hybrid of stratified sampling and opportunity sampling. To do this, we first of all split the population into groups based on a characteristic. This is a bit like the stratified sampling. Then we determine the number, which we call a quota, of each group needed in the sample. Now, unlike stratified sampling, it doesn't necessarily have to be the case that the population and the sample have the same proportions, but it could well be if you wanted it to. Then we observe or measure the items in an opportunistic way, and then we assign them to the appropriate quota using judgment. If an item corresponds to an already full quota, we skip them, and then we continue until all of the quotas are full. Let's have a look at this with an example. Imagine the head of sixth form wanted to interview some of their year 12 and 13 students, and for whatever reason they've decided they need a quota of 6 year 12 students and 9 from year 13. We then need to sample the students in an opportunistic way, so this could be as they arrive to school in the morning. So if the first student that arrives to school is in year 13, we include them in the sample. You can see the second student's in year 12, so we include them. And then we continue to include all of the students as long as the quotas are not full. So if we continue, as students arrive to school, you'll see that eventually the year 12 quota is going to get full. So at this point here, we have all of the quota for year 12 because we only needed 6 of them. So when this next year 12 student arrives here, we don't include them in the sample, and instead we skip them out, and we continue filling the year 13 quota until we've got 9. At the moment we only have 7, so we have another one, and next we have a year 12 student, so we ignore those, and the next year 12 student we ignore those, and then we get a year 13 student, and we've hit the quota. So we've now finished the sample. Finally, for quota sampling, you need to know the advantages and disadvantages. In terms of advantages, it's relatively cheap and easy to do, much like opportunistic sampling. Additionally, it's possible to have the sample structure reflect that of the population, a bit like with stratified sampling, and this can sometimes be helpful. And since we're not randomly selecting any numbers, we don't need a sampling frame. In terms of disadvantages, well, just like opportunistic sampling, it's not random and can be biased. In our example, where we sampled students as they arrived to school, it may well be that the students that arrived to school early or first have similar traits, and those that arrived to school much later are not represented in the sample at all. Thank you for watching this video, I hope you found it useful. Check out the one I think you should watch next, subscribe so you don't miss out on future videos, and why not try the exam questions in this video's description.